Okay, imagine this. You got 3 glasses of liquid sitting on a table. At a quick glance, they might look kind of similar, just different colors. But what if I told you they represent 3 totally different types of substances and that they are all around you every single day? So here are our 3 mystery glasses. We've got some clear salt water, some cloudy milk, and some murky, muddy water. I mean, they're all just stuff mixed in water, right? Well, not quite. The real difference between them is the secret we are going to uncover together. So what's actually going on inside these glasses? To solve this little mystery, we first need to understand the family these things belong to. So let's start by mapping out the mixture family tree. Now, the most important word to focus on here is physical. When you make a mixture, you are not creating a brand new chemical. The salt in salt water, it's still salt. And the water is still water. They're basically just hanging out together. No chemical bonds are being broken or formed.
Okay, so the mixture family has 2 big branches. On one side, you have your homogeneous mixtures. Homo means same. Think about that salt water. Once you give it a good stir, every single drop is exactly the same. You can't pick out the individual salt bits. But on the other side, you've got heterogeneous mixtures. Hetero means different. The easiest example, a salad. You can clearly see the lettuce, the tomatoes, the cucumbers. It's not uniform at all.
So this family tree right here shows us exactly where our mystery liquids fit in. You see, all solutions, like our salt water, are homogeneous. But here's the twist. Both colloids, like milk, and suspensions, like muddy water, fall under the heterogeneous branch. And that is our first major clue, because even though milk looks totally uniform, chemically speaking, it's not. So if just looking at them can be tricky, how do we tell them apart for sure? Well, we need a toolkit. It's time to introduce our 3 forensic tests that will turn you into a mixture detective. And this is it. This is the absolute key. It all comes down to size. Not what the particles are, but how big they are. This single factor is what separates a solution from a colloid and a colloid from a suspension. In a solution, the particles that are dissolved are incredibly tiny. I mean, we're talking about individual ions or molecules, less than a nanometer wide. Then you have colloids, where the particles are bigger, in this kind of middle range between 1 and 1,000 nanometers. They're large enough to have an effect, but still small enough to stay suspended. And finally, in suspensions, the particles are absolute giants in comparison, over 1,000 nanometers. They're so big, you can often see them, and they're way too heavy for the liquid to hold up forever. So based on those massive size differences, here are 3 simple tests. First, the look test. Is it transparent or is it cloudy? Second, the light test, and this one is our secret weapon. And third, the time and filter test. What happens if you just let it sit for a while? You know that light test actually has a cool scientific name, the Tyndall effect. Have you ever seen those sunbeams cutting through a foggy morning, or dust particles dancing in a ray of sunlight coming through the window? That's it. That's the Tyndall effect. The bigger particles in colloids and suspensions are large enough to literally scatter the light, making the beam visible. But the tiny particles in a solution, they're too small. The light just passes right through. This is a dead giveaway. All right, we've got our family tree, we've got our detective toolkit, and we know that particle size is everything. It is time to crack this case. Let's apply our tests to those 3 glasses. First up to the interrogation table is glass number 1, the salt water. Let's run it through our tests. Okay, let's check the case file. The look test. It's perfectly uniform and clear. Check. The light test. Shine a flashlight through it, and you can't see the beam at all. Check. The time test. Let it sit for a week, a month, a year. That salt is never going to settle at the bottom. The evidence is overwhelming. Verdict? It's a solution. Next up, our second suspect, the glass of milk. Now this one looks uniform, but is it hiding something? Let's see what the evidence reveals. So here, it's the combination of results that tells the whole story. Look, test. Yeah, it appears uniform, but it's cloudy, not clear. Time test. The little particles of fat and protein, they don't settle out. But here it is, the smoking gun, the light test. A beam of light is clearly visible. That's the Tyndall effect right there. So, it doesn't settle, but it scatters light. Verdict, this is a classic colloid. And that brings us to our final glass, the muddy water. This one seems pretty obvious, right? But a good detective always confirms the evidence. Let's look at this last case file. Look test. It's clearly not uniform. You can literally see the specks of dirt floating around. Light test. Yep, the beam is visible. But here's the key piece of evidence that separates it from a colloid. The time test. Leave it alone for just a few minutes, and what happens? The mud sinks right to the bottom. It settles. Case closed. Verdict? It's a suspension. So, we've solved the mystery of the 3 glasses. Awesome. But this isn't just some lab experiment. Now that you have the tools, you can start identifying these mixtures absolutely everywhere. Let's take a look at your world of mixtures. And you'll see just how common they are. I mean, the very air you're breathing is a solution of gases. That mayonnaise in your sandwich? Total colloid. And that glass of orange juice with pulp is a suspension, at least until you shake it up. You're literally surrounded by this stuff. So, let's wrap this up with the most important points to remember. 1. All solutions are truly uniform, they're homogeneous. 2. Colloids and suspensions are not, they're heterogeneous, even when a colloid tries to trick your eyes. And 3. The fastest way to tell them all apart is to think about particle size, because that determines if they scatter light or settle over time. So, now you have the detective's toolkit. You know the secret isn't just what's in the mixture, but the size of what's in it. So the next time you see something, ask yourself, is it clear? Does it scatter light? Does it settle? What kind of mixture is that salad dressing, or that morning fog, or even the sky itself? The answers are all around you.